I'd like to introduce Frank, a geotechnical engineer. He's going to tell us about moisture, how it changes when building occurs, and some other things that we need to know. Frank.
Thanks for the welcome. Now, I'll touch about a few things, and I guess if someone wants to interrupt me, I don't mind. Put your hand up, and we can talk a little bit more about it, because it's sort of. I'm a civil engineer, became a geotechnical engineer, so that's sort of my background. So trees are, I guess, to some extent for us, a challenge in terms of how do we overcome and avoid distress of buildings and houses and roads and things like that. So I'll sort of give you some experiences where I can sort of demonstrate how the moisture has changed due to construction or drainage or those sorts of things. So the first thing that I'll just touch base briefly, and it's very similar to the land channel. There's another web page which we use, which is called GeoVic. Similar sort of style, how do you use it and all that sort of stuff, and it gives us the geology of different areas. So this is I think the City of Kingston sort of area, and I just sort of highlighted some just everyday sort of geology in this sort of area. And obviously swamp deposits is a geological type or soil type that you can sort of say sands, clays, and the soils are going to be predominantly wet. The coastal dune deposits, again, we're talking about sands, so that's something else again. And then we've got the Brighton group, which is basically a mixture of sands and clays and those sorts of things. So I'm not going to go too much about the soils, but it's good to look at these geology maps, and they give you a rough idea of what you're likely to encounter for your trees and things like that. So that's just another one showing I just sort of want to highlight that in the west of Melbourne, which is pretty much the top of the bay to the west, is where we've got our what we call basaltic clays, which is more the heavy clays in the rock. So that's a sort of a different element, and from a tree perspective and moisture variations and those sorts of things, those soils are highly volatile to shrinking and swelling and creating distress to buildings and that sort of stuff with moisture change. So obviously with trees, they love to extract the moisture out of that soil, so they will create the shrinkage and sometimes create distress to buildings. This is again just a simple chart that we use from I guess a soil strength for when I'm looking at designing roads and working out if I know that I've got a weak soil, I need to build a thicker pavement. When I'm dealing with sand, the pavements in terms of thicknesses can be a lot less. The structural requirements are less. But for you, what we're talking about when we're talking about high plasticity clays, we're talking about materials which tend to be weak. Obviously, with the car park out there, you saw the clays. We've got heavy clays out there just under the topsoil, and it gets very soft underfoot. So that's where we get weak soils. But also with the clays, we're looking clay-type soils. We're looking at materials which can have a high moisture content. Whereas sands, we're looking at very sort of low moisture content, but very high strength and obviously good drainage characteristics. So all those sorts of things are sort of influential on the trees. Just to break down the soil in terms of its constituents to some extent and simplify things, is obviously there's a component of air, a component of water, and a component of solid. So that's obviously what the air and the water is what the trees are after, and obviously there's some nutrients in the solids. I'm not a tree expert, but that's what I know about. Obviously, when we get fully saturated soils or waterlogged soils, then obviously the air content's going to sort of be expelled, and we're going to have a high water content. And when we've got a very dry soil, which is maybe due to drainage or trees, just except too many trees, obviously the water content's going to be very less, and we're going to have a high air content. And with that, obviously we get a shrink, and with water sometimes these solids will expand and obviously swell. I won't go into too much detail about this diagram, but it just talks about density and varying moisture contents and how we can get compaction. If you need to know more about that, I can talk to you about it later. In terms of the defects that we see in roads, that can tell us a lot about soil moisture content. Now, these ones are more about the distress that we see, which are more structurally related. So the rutting is obviously the cars doing that. The depressions is usually a compaction or a trench where we've got subsidence. Corrugations is poor mechanical interlock in the road in terms of the surfacing, and the shoving is more braking and turning forces. So I just wanted to highlight those defects we're not worried about with regards to trees. But the next ones, when we're looking at the cracking, it's probably these sorts of defects are often what we see in terms of moisture. These are moisture related. So the longitudinal and the meandering cracking and those sorts of defects are often associated with trees or a drainage issue. So there was a lot of large trees behind me when we did this investigation to work out what was wrong with this road. And we did notice a lot of trees sort of invading the road. So this is where we see we got this meandering cracking. So that's quite common in a situation where you've got a lot of trees in a road or a footpath and those sorts of things. Now, from a geotechnical engineer perspective, this estate isn't that old. That was roughly new in 2013, so it's sort of 3 years old now, maybe a little bit older. And we've got this longitudinal cracking. So what's basically happening is we're getting a drying effect here, which is causing this to sort of rotate and shrink, and therefore breaking it like a Scotch finger. And that's why it's a constant pattern. It's not like the meandering one where it's going everywhere. It's not random. This is actually a drying effect from these trees here, and that's sort of breaking the road in half. Now, I've got it better in the same estate. We did an investigation. We did some moisture contents here, did another moisture content here, and we did some moisture contents just in the edge of the nature strip. I think the next slide highlights it a little bit better. So the concern with the council was that it was sort of starting to happen in a brand new estate. These houses have still got blue board on them, so it's relatively new. And they said, what's happening here? Why are these roads cracking the way they are? And these trees were only young then, so you can see the difference in the size. But this wasn't so much the trees, but more so the drainage. And what we did is, again, going to 1, 2 and 3 and sort of 1, 2 and 3 is sort of dictated here. And the dark colours are high moisture content, and then we get a light moisture content, and then towards the centre of the road we get down deep, and this is near the surface, and that's the depth there. We're getting an increase in moisture content here as well. So with borehole 1 being in the nature strip, what we'd found is an agricultural drain or aggie drain which was drying out the soils here. So you can sort of see the influence that they were creating is actually drying out the soil quite substantially. But then in the centre of the road we've got a very high moisture content. So that's I guess an example of what effective drains can do and create those sorts of distresses over time.
Is that cracking also partially in relation to vehicle compression?
Yeah, no, these are. I've done examples before where we're at like that. Just say this was a dead end court where it's had absolutely no traffic on it. It's got a no through road sign. No traffic could go through it. So all these defects are what we call environmental defects. They've got nothing to do with structural defects. Those other defects, and it's a good question you asked because it goes back to the couple of slides ago where I was sort of going about. These defects is what you'd say are more related to vehicular traffic defects, whereas these sort of cracks, if you like, are more related to moisture changes. So I'm glad that you brought that question up because it probably makes it a lot clearer that it's not traffic induced. This is definitely a moisture relation. And we were able to, I guess, demonstrate that because with this was in a swamp deposit, so the clays here are very volatile to moisture changes. So again, it was sort of illustrated with this graph that, you know, obviously it's dry on this side and it's wet on that side, so you can imagine a swelling force creating that. And we're getting seasonal fluctuations too, where sometimes these aggie drains can actually be a source of water too, because although they're supposed to extract water out, when they're in the winter months, when they're really working hard, they probably can't extract it and probably letting more water into the soil. So they're creating that fluctuation. This is, I guess, a good example, and I can't remember the exact circumstance why we went back, but this was an artificially grassed surface soccer pitch. So I think that's the same light pole there as there, unfortunately. I should have moved that picture over a little bit when I first took it. But what you can see is the average moisture content here was about 26.5% moisture content. Once they're built, and it's not like they've just put the artificial turf straight on top of the ground, they put some crushed rock and those sorts of things. So by doing that, they've minimised the evapotranspiration with regards to how much the grass takes up, but also the evaporation sort of provides a bit of a sunscreen from that water from escaping as well. So it's a pretty substantial increase. You're talking about 6%, which is quite a lot. And I think obviously, from my perspective, if we had perimeter plants, that obviously you can sort of see the grass was hardly surviving here, but with a 6% plus sort of moisture content increase, the trees are going to be attracted to that area because that's obviously where the moisture content is now. This is, I guess, just again an illustration. That's just the top of the clay. So it just sort of highlights that we obviously get these seasonal changes, and I think it's very similar again to that car park situation where we can get the wet soils and then they end up sitting on the clay and you get this massive amount of water sort of sitting there. Remembering that illustration, in all the new construction, new subdivisions and all that sort of stuff, they'll try to eliminate that process because they want to strengthen the soils for road construction, for houses and all those sorts of things. So it's very common that we'll get the Aggie drain just into those clays and try to remove a lot of this excessive moisture from a constructability perspective. So this is, I guess, just another example of where we've taken moisture contents to prove the reasoning for distress. So that cross-section, that's number 1, 2 and 3, so it's a bit blurry there, and obviously that corresponds to the sort of plan view that I've tried to illustrate. And I didn't show you all the defects, but we had sort of cracking here and here, which is basically in these sort of locations. That was a 2-storey section there. And we had a lot of cracking at this area here. We've got obviously a large row of trees on both sides. Now when we look at the moisture contents, we obviously took some various moisture contents with depth. This one with an average of 25. Here we've got sort of very minimal trees. We've got 36, and then we've got sort of 30% over here on this side again. So again, you can sort of see with the drying, you're going to get a shrink. So that obviously, as I said there, it's a low moisture content. The house is sort of going to want to come down there. If that's a high moisture content, is it going up? And this is the thing with geotechnical stuff. We don't know unless I take a lot of moisture contents over time. Is it getting wetter or drier? Is there a leak underneath the house? It's not actually the trees drying it out. Is there actually like a plumbing leak here that's making this go up? And obviously those two look being relative. We don't know 100%, but I think in this case, because we've done the investigation, there was sort of nothing that looked like leaking or anything like that we can sort of indicate that it's likely to be the trees drying the house on both sides. So I guess that's another good illustration in terms of how trees are actually creating an influence to the moisture content. And like I said, if you're looking at it from a tree perspective, you've got 36% moisture content. So where do the tree roots want to be? You know, where it's dry, where they're competing, or where there's sort of lots of available moisture content. This is just, I guess, a typical Aggie drain of what it does, and I guess its purpose. And obviously, the depth of this drain can influence the moisture contents quite severely. This is a lot of air voids. So, like that diagram before, when we've got a lot of air that allows for it also to be collected, and these soils can dry out quite significantly. Talking about the excavation, obviously sometimes even a trench, and particularly if it's quite deep, you can't say it's going to be 300, 200 mil wide you know, if it's significantly deep. If it's going to be a quite a large infrastructure project, they have to build it in stages, otherwise they get a collapse. So this is, I guess, the ideal sort of trench. Yeah, it's 400 whatever wide, but the reality is in construction that you'll obviously have this sometimes a batter or stepping in terms of the excavation to allow for that. So from your tree perspective, you know that it might show like a trench 400 wide. If it's a deep infrastructure project, it's going to be a lot greater than that. This is, I guess, it goes back to what we just had in that last discussion in terms of, ideally, if the soils can stand up, the excavation of a basement will be vertical, but that's obviously not always the case if we're dealing with sands or wet soils and those sorts of things. So it's very, very common that you'll get this sort of batter slope. So obviously, on the plan, the building will sort of be shown here. They don't tend to show the, let's call it the excavation constructability element of a basement type construction. So, you know, you're going to have quite a depending on the soil type, going back to geology, and again, if you're in a swamp, you know that you're not going to be able to cut soils in a vertical angle in something that's described as a swamp. I say to people, Mother Nature put swamps as flat, so you wouldn't expect that you're going to be able to create you know, vertical cuts and that in a swamp type geology. So that's just sort of, I guess, just a practical observation. Now this stuff here is actually like a drainage mat, so it's very similar to just creating that void, because obviously we want to keep the wall nice and dry. If any water does sort of come in here, it tends to get collected in this aggie drain. So the zone of influence in terms of the moisture content can be sort of probably at you know, as a rough estimate, probably 45 degrees or something like that, where you're going to actually influence that any trees or any soil moisture content for the lifetime of the project. As long as that aggie drain's working, it's going to be taking moisture out of that soil. So the other thing is that, don't forget, there will be, sometimes these aggie drains don't work that effectively, so the moisture content might actually be down here, and the trees are going to go chase where that moisture content is. In terms of probably something that has less influence is those sorts of pile retaining walls, because they don't have that over excavation element, and they tend to, if you look at a lot of underground car parks, they'll end up backfilling that with shotcrete and maybe put a little strip drain in there to allow for water pressure to be dissipated and all those sorts of things. So in terms of, if I was looking at trying to minimise defects to it or potential moisture conditions to a tree, this sort of type construction is probably going to be the best in terms of, because it doesn't have the same sorts of drainage characteristics as the previous slide. So if you look at that, you can see that that's all going to be filled up with scoria. Its main purpose is to dry out the soil and collect water, whereas the pile type situation is, it's mostly soil, so it's mostly leaving the soils intact, and you know, you're only going to put a small drain through there possibly with a weep hole, and then shotcrete in between. Now I'll just touch base on I guess the water sensitive urban design element, and that's sort of starting to come into more smaller projects, and obviously that can sort of create problems potentially for your trees and obviously houses. Any time we're creating changes in moisture content, we're potentially going to create problems to structures such as buildings and houses and things like that. But also, you know, trees with an excessive amount of water, they're going to be influenced as well. So it does depend how much soil absorption you get in through the soil profile, will depend on its material. So if you're looking at, again, we're looking at something in the western suburbs where I'm talking about the heavy basaltic clay with the boulders in it. It's predominantly very heavy. So this sort of situation in terms of a water sensitive urban design project, it's not going to allow any, it's going to be basically a dam. It's like a clay liner. It's not really going to dissipate much water. So I got a question at the back?
I've just got a bit of a question. When you've got those very reactive soils and people tend to start building on off slabs or using a pier and beam sort of footing, would you expect to see that type of problem?
Yeah, well, we do. We're starting to see more problems. And I guess the standard has only just sort of emphasised it with a full chapter in the appendices now. This is the residential footing, slabs and footings code, which is dedicated a whole chapter to trees now in terms of how we deal with trees. So what I say to people is, yes, there is houses with normal footings that are 100 years old that have survived and they're fine. But I think people's perception of the performance of their houses is much higher than it was in the past. I think people maybe 30 years ago said, well, I've got a big tree and I've got a crack, I just have to live with it. That's Mother Nature. Whereas these days, someone spends, their life savings on a house. They say, I don't want to see a crack in the house. And I can say fair to that as well. But I think it's with people's perception, what I say to them, it's like insurance. If you want to have virtually no cracks in your house and have really high level of performance, you're going to have to pay for it. And it's like it's going back to that type of situation where you've got a really deep foundation. We know at this sort of depth, and again, we're talking about a normal house, so we wouldn't have the basement so much, but with a pile type foundation which is really deep, the fluctuations aren't going to occur down deep. So the trees aren't going to have the influence. The trees have got the ability to go in between the piles and get their moisture, but still not influence the house. So the answer to the question is, yeah, if you want to have a little bit higher level of risk, you can have your normal slabs and footings, but if you want to sort of have some additional insurance, then you go for the sort of deeper foundations.
Because as a follow-on from that, what I've come across when geotechs generally get involved, they then recommend that there's root barriers installed all over the place to protect the building.
Well, that's another option, because I guess like with a true root barrier, it's almost like saying I want to create a barrier around my building which is going to stop moisture fluctuations. But what we've found is that trees will do whatever they can to get to that. If it's just like a kid in a lolly shop. The lollies are just over there, and I want to get to them. And that's what the trees will do. They'll jump the tree root barriers. They'll go under them. They'll go around them, or there'll be a break in the tree root barrier, and they'll bust through. So,
I guess the other thing too, a lot of the engineers specify concrete root barriers still.
Yeah.
And they're inadequate, really, setbacks. So there's no, they're not really providing the resources the tree needs.
Yeah, so I guess engineers are thinking, I'll be honest, we're thinking from a structural viewpoint. If I put a barrier there, it's going to just stop it, and maybe it's a protection for the house. Before the tree roots get to the house, they'll stop at the tree root barrier. But I think in some ways, like I said, if you go for this type of concept, you just let things happen, and the trees sort of go, they can sort of live together, and everything sort of works. But these sorts of things you're talking in the tens of thousands compared to a tree root barrier. So it's all down to cost. And like I said, it's like insurance. If you've got a $2,000 car, you'll go, I'm just happy with third party. But if you've got a $200,000 car, you might want to get fully comprehensive. So it's the same with your house, But clients don't. Some clients want the geotech just to sign off, or you guys to sign off that nothing's going to happen. And they're only just using us for insurance. Whereas you say, well, you spend another $30,000 on deep foundations, and that's your insurance. Don't use us for your insurance. About the water sensitive urban design, like I said, that's starting to create another element. Like in Roman days, it was always take the water out of the roads or away from the infrastructure. Now we're putting it back in with this water sensitive urban design. So we have seen some defects in roads due to this concept, but again, it just relates to where they're located. So down Sorrento, Rye, they've been using soakage pits they haven't got formal stormwater drainage. It all just goes straight into the sand and then and disappears basically. Whereas in the western suburbs, you can't do that. It's like I said, then that's where you've got the opposite. You've got like a clay liner. You're not going to get rid of that water as easily. So there's an element to water sensitive urban design that needs to be considered. These are, again, just soil descriptions which I've just kept for you guys just to sort of get an idea, and this is what we'd sort of say is what we call coarse material or coarse grained soil, so that's your sands, and sands can sort of be table salt or sugar is probably the finest sort of sand, and those sorts of moisture contents, generally these soils are more permeable and have low moisture contents and probably don't have that much need for agricultural drains and don't create that much distress to houses. Whereas when we're looking at organic clays and clays of high plasticity and those sorts of things, that's where we're starting to look at these higher moisture contents, so that trees are going to want that moisture in those clays and extract it out of them. And then we just talk about the various permeability. So again, gravel's got a very high permeability, whereas clays we're going to have a low permeability, and these are the sorts of filters that they use to extract the water. This is a table, again, it's more again for the geotechnical engineers, but it just sort of highlights a little bit of expansive nature and those sorts of things. So we basically categorise it as low, moderate, high and very high. Probably the swell is a simple test that we do, is where we remould soil into a mould, put it in the water for 4 days, and then just measure its swell potential. So that gives us an indication of its volatility to moisture changes. And that's basically it. But I'm open to questions if you've got any.
So soils, do you have much knowledge with tree roots and
Yeah, well, I'd say anything that we determine as what we say is highly reactive is the ones that we're going to sort of suffer with. I think from your perspective with regards to going back a couple of slides, it's probably illustrated well in... Is this one, whereas with sands, they've got probably a very flat batter that they can be excavated to. You're not going to be able to, again, excavate sand to a vertical cut. Whereas heavy clays, a bit similar to this one, you are going to be able to have that ability to cut them virtually vertically, provided they don't get wet and all those sorts of things. So, yeah, it just depends. All the soil types have got their good things, like sands don't have the influence, whereas clays do, in terms of defects. So they've all got their pros and their cons.
Just going back to the roads examples.
Yeah.
Is that not just an example of poor road building and construction? Shouldn't they have known what the soil was going to do and that there would be a street tree?
Yeah, well, we are learning now over time, because this was some designers were still not designing them properly in terms of we've got to have a reasonable amount of cover, even for a bicycle track, and people will laugh, is that we need a pavement which is about 400 thick, even for a bicycle path, and it's got nothing to do with the structural component of the bicycle traffic and pedestrians. It's all about the reactivity. So what the cover does is provide like a sunscreen over the top of the heavy clays to stop the volatility of the shrinking and swelling over that season. And just for your information, just from the footings and foundation information that we know, that the influence between summer and winter is about 1.8 metres. So the soils those moisture contents get influenced to about 1.8 metres. And obviously the trees can go, depending on what type of tree, and I've had a quick discussion with someone else before, depending on the type of tree, that trees can have greater or less influence.
Is there an effect on the moisture content at the time of building the road as to where it ends up?
Yeah, that's right, because what we try to design for and consider is what we call an equilibrium moisture content. Where's this road or where's the clay going to be like? And I guess that goes back to, I'm not sure if it's back or forward, the example where we showed this one, where we had a 26% moisture content. You can see it's dry as a chip. You're not going to get bogged or anything on that one. So the time of construction is fantastic now, but it actually got wetter over time. So the time of construction is quite critical from a construction perspective. The equilibrium moisture content's a difficult one to know, because it all depends on what they do at the time of construction, like aggie drains and all the rest, how that will be influenced in the longer term.
Is there a certain soil percentage where the soil becomes uncompacted, like when it gets up on a very high level?
Yeah, well,
your compaction layer, or
I'll go back to. That's probably a good one to explain with this graph that I was touching base with before. So, in terms of if it's a level 1 site, so most new residential subdivisions are what they call their controlled fill. So the fill's supposed to be compacted at a certain moisture content, and it's supposed to be compacted at a certain density. So that'll avoid settlement of the houses and that in the longer term. So what there is actually a density curve. So if you try to put the soil in really dry, you can't actually, with the heaviest machine there is known to man, you can't actually get any more compaction because there's a friction against the materials that doesn't allow the particles to get close together. And then there's a saturation point of view as well, where the water starts to basically, the soil starts to bounce, the machinery starts to bounce off the water because water's incompressible, so you get that sort of situation. So there's what we call an optimum moisture content, where you'll do the least amount of effort at this particular moisture content, and this moisture content is very close to what we call the equilibrium moisture content, where it's likely to be stable in nature. So what you find is if you get a site where they excavate and they go do a cut and fill, the moisture content's the same, the fill goes down quite nicely. But if they let that soil dry out too much, they're wasting their time when they come to compact it because it doesn't get sort of compacted. So to answer your question in some ways, is it doesn't matter in terms of its dry weight when the fill gets placed. That can influence the long-term conditions. Because the other thing as well is you get a higher void ratio. Like again going back, if you've got a lot of air, which is something which is really dry, or even this one, that's got 0 tonnes per cubic metre, and so you're actually going to have quite a low density, and you're going to have water readily getting into that air void to fill it up if you do get a big downpour or anything like that.
What did that house that there was some heaving and shrinking happening? Was that your job?
Yeah, it wasn't our job, but we do sort of forensic investigations to work out what went wrong.
Recommending?
So we recommended to I can't remember exactly. It was quite a few years ago. But
remove or root barrier?
Yeah. Well, what we probably said is we told them what the cause was, and then we sort of left it to them. So we didn't. I don't think we come up with a recommendation as such. But
were they neighbouring trees or were they their trees?
Yeah, they were. I think the neighbouring somewhere between those two. So yeah, they were his own trees. But I guess once they know the problem, the only problem with, like, people say, oh, let's just underpin, but underpinning is just a huge cost. And the problem is, if you underpin this part of the house and you don't underpin that section, you're basically creating a structural problem that any time you do something different across a building, you're going to get a defect somewhere else.
If you removed all those trees, wouldn't you have a really big change in the moisture content?
Yeah, 100%. Yeah, so that's the other thing is when we say to do things, we say to sort of do them gradually if you can. Predominantly a lot of the defects that we observe are broken pipes and those sorts of things, which have an easy thing to fix, but we say don't do any crack repair or anything till you fix that plumbing leak, because like you said, you're just going to go back. And this is exactly the same thing. You take all them trees out, you're going to get back to 36%, and up she's going to come. So you just sort of, if you are going to take the trees out, you'd have to sort of wait a year, 2 years before you do sort of any other cosmetic repairs. Yep.
Does the permeability of bitumen change with age?
I guess it would in terms of that it gets cracked, but a lot of people think that the asphalt is impermeable, but it is permeable. So I've dug a lot of holes in roads, and it's definitely easy to dig under the road, the soils, than it is in the nature strip, and that's just due to that. It's got that sunscreen layer, so we don't have the evaporation coming out. So it's actually more moist under the roads than what it is in the sides. So And I'll be honest too, the trees, I'm going to dig in the shade because I'm going to dig a test hole in the shade, and it's always harder because the trees take the moisture out of the soil. So, you know, in the hot summer days you go, I'm going to do a hole under the shade, and it's like the worst thing because it's always harder there.
Okay, thank Frank.